already, welcome back everyone. It's your main math man, Mr. Shen, coming to you live from Summit Academy. In this video, working on some financial algebra, and this is going to be the Unit 1, Lesson 3, talking about being able to create expressions in function notation, find the domain and range of a function, and we will be able to evaluate functions for a given value. And we'll talk about these three things throughout the video. So on the first part, it's just kind of talking about what is a function. So it says a function is a relationship between an input value and an output value. So it's just saying where each input value has only one output value. So if it has multiple, then we know it's not a function. So it says, for example, the function f of x equals x squared, that quadratic function, that parabola that we're used to seeing, can say is a function because no matter what the value of x is, x squared only has one value. However, for if we had f of x squared equals x, then f of x equals plus or minus x is not a function because every x value has two values for f of x. So that just means for every x there is two y's, which we do not want. Alright, so instead of using lengthy verbal descriptions like you did in the intro activity, you can use an equation to describe what a function will do. So function notation is always to express how the function transforms the input into the output, such as f of x equals x plus 5 would be a linear function like a straight line. This means that this function named f operates on the variable x. So when we say, that's why we say f for a function in terms of x, because on the right side of our equation, notice how it's only x. So we say f of x and then it adds 5 to it. And it says if you put x into this function, f of x tells you what comes out, which would be your y value. A few things to remember about function notation. Got three things here. So it says the input can be represented by any variable, though x is most often unless another variable makes more sense for a particular problem. And what we'll do is anytime we're graphing out, we want to make sure that we're using in terms of f of x and x. And then it says that the output is represented as f of x, which reads the function f of x, or just f of x for short, which is what I've been saying this whole time. So again, it's not f times x, it's not f parentheses x, it's just f of x. And it says the most common letter to define a function is f, though any could be used. For example, you can have g of x, h of x, or m of x as just some simple examples. So let's also just make a note. So let me write this down for us. When I say, let's say this as well. So any time we graph on Desmos, we must use x and f of x. Again, where f of x is the same thing as just y. So just make sure you're remembering, again, that simple rule, so that way we can graph out what we're looking for. Okay. So, looking at example 1, it says Johnny triples his money by investing, and then pays $2 in capital in gains taxes when he sells those investments. Write this using function notation, again f of x, and it says where x is the amount of money Johnny starts with. So what our first step is, so it gives you an example, and then it shows you what it looks like on the right side. So it's going to say represent the steps of the function. So write the steps in order they happen in the function using an input value. So again, if we had a number for x, we start with that number, we multiply x by 3, and then we subtract 2 from the result. So then so we can kind of write the steps down and kind of figure out what we need to do. And then for the second step, we can say write an equation for the function. So use the using parentheses initially may help keep track of the order operation. So I like to use parentheses anytime I plug in that value for x, but we can write it like this. So they have f of x equals x times 3 minus 2. And make sure you can kind of group that together, so our final answer, our final function, is going to be f of x equals 3x minus 2. So that's what would be the final result, and that makes sense because it's saying Johnny triples his money and then pays $2. So that's why it has minus 2, because of the that he has to pay the capital. All right, so let's see if we can practice it. So it says functions are a perfect way to concisely describe situations and begin to calculate outcomes and make comparisons. Practice writing functions for each of the scenarios below. So I'll do a couple with you here. So it says model the function for number 1. It says model the function f, which operates variable x by adding 2 and then doubling that quantity. So again, what we're going to have, I know it starts with f of x because that's going to be my one side, and I can say, well, I have to have something all together, so I'm going to say 2 times and then the quantity, so it's going to be x plus 2 inside of my parentheses. So let me see if that's doing what it's asking. It says model the function f, which operates on the variable x by adding 2 and then doubling the quantity. So again, that double is on the outside for this situation. All right, and then in number 2, it says Jeremiah makes $15 an hour working part-time at a local fast food restaurant. He pays approximately 11% in taxes on his earnings. If H is his hours worked, model his weekly after-tax wages as a function WH of hours worked. All right, so a couple ways to write this, but I'm going to write it like this. I'm going to say, okay, well, again, since it gives us what our function is going to be, again, it says W of H, so I'm going to say W of H. And we're going to say, well, if it's $15 an hour, we're going to say we have 15 times X, and I'll give that example here in a second. And then it says approximately 11% in taxes. So we can say that's going to be like this. We're going to say minus 0.11 times that 15 times H. And I want to have it all in one amount. And so you could say or you can write it like this. I like to write it as one equation, meaning one variable on our right side. And so I could say, well, that would be the same as 0.89 times 15h. And the reason why I get that 0.89 is because it's taking Jeremiah is making 89% of his wages because he takes out 11%. So that's where the 89 comes from, because 1 minus 0.11 equals 0.89. So if you're wondering where that came from, that's what it did. All right. So now for this one, for number 3, it says Sarah goes to the grocery store and buys 4 packs of gum. Sales tax in Connecticut is 6.35%. If G is the price of a single pack of gum, write a function P of G to model the scenario. So let's write our function. So we're going to say, one side is going to be P of G, again written with those parentheses, and our right side should just have that variable. So I'm going to say something like this. So if I wanted to say, the normal price would be 100%, I would have to say 106% of the original price. So I'm going to write like this. I'm going to say 1.0635 because I'm adding that percent to the whole 100% of the normal price. That would be times the 4 packs of gum, so 4G. So that's one way of writing it. Or you could say like this. I could say or I could say still P of G is going to be our left side. So our function P in terms of G. So I'm going to say, okay, I have 4 packs of gum, which is what we start with, plus I have the sales tax, which is 635 times 4G. So again, this is, if I wanted to label these different parts, I'd say this is the 4 packs of gum, and this would be sales, or let's say price of 4 packs of gum, and then this right side would be sales tax of 4 packs of gum. So notice those different parts. When you're creating your function, you want to make sure you see those different parts. And notice how I'm not graphing it, because these functions are not in terms of x and y, so that's why I can't be graphing these yet. And then for number 4, it says Janet rents a booth at the farmer's market that costs $150 a day. She sells jars of fresh honey from her family farm for $8 each. At the end of the day, she splits all the money she brings home with her mom, who takes care of the bees. If J is the number of jars of honey sold, write a function f of J representing how much money Janet makes each day. So I'm going to say, okay, this one's going to be a little bit different now. I'm going to say f of J like that. And I say equals, let's see, well, we said we have $8 for every jar, so I'm going to say 8J, and then the booth of the market is $150 per day, so we say minus 150, and if this f of J represents how much money Janet makes, we can say we have to divide this by 2, because she splits the money between herself and her mom. So we'd say this is going to be our function f of J. Alrighty, so now on the next part, excuse me, on the next part, when we are evaluating functions, so before we were just writing, so this was, let's say this was writing functions. So now what we're going to do is we're going to say, okay, what happens when we need to evaluate functions? So when we evaluate functions, again, notice how it has that kind of that root word in the middle, has value in it. So we're plugging in, so plug in a value to get an answer. So this should be from Math 3, but right, and Math 2, but I want to make sure that you're seeing how to do it right now. So evaluating functions is the process of finding the output value of a function for a given input value. To do this, substitute the input value for the variable and then simplify the expression. So this is exactly what I'm saying. Usually, again, we're going to plug in an x value. So it says, for example 2, it says Maritza earns $18 an hour tutoring at the community center. On weekends, she is paid a bonus $15 per shift, and it says how much money would Maritza earn for working 6 hours on a Saturday. If x is the number of hours worked, solve the function f of x for x equals 6 hours. So first step, what is our function? So express using function notation. So we have so this is write the function. So we have, again, f of x is what? Money earned. Can we say money earned? Yeah. So this is money earned. And it says right here, if X is the number of hours worked. So we could say this is hours worked. So again, be careful when I'm looking at those two things. I'm talking about, f of X is money earned, where X is hours worked. All right, second step is to substitute for input value. So let's say replace X with 6. So as we rewrite it, we say f of 6. And anywhere where we have an x, we now have a 6. So we say f of 6 is equal to 15 plus 18 times 6. And then when we solve, we just simplify. Again, make sure you can use your calculator if you need to, or use those order operations carefully. So what that means is this. We just say, okay, we plug in the value, so f of 6 equals 15 plus 18 times 6. Then we say, okay, 18 times 6 is 108, and then 108 plus 15 is 123. So that would be our final answer. F of 6 equals 23. But what that means is, again, notice how they write a sentence. They say write a sentence for the situation. Because f of 6 equals 123 doesn't tell me what it's asking for. It's asking for how much money would Maritza earn. Well, she would earn $123 working 6 hours on a Saturday. So make sure you can see those different parts that it's trying to explain. Okay, so this is what happens when we evaluate our function. And so the next part after that is what happens when we are looking for the domain and the range. This is really simple. Talking about the domain and range describes the limits of the function, meaning the bounds. And what I mean by that is the domain is the set of all possible input, meaning x values, and the range is the set of all possible output values. That just means y, which is the same as f of x. So it says you need to know the domain before you can determine the range. So we usually, and that makes sense because we always are, range is the dependent variable because we are dependent on what we put into the function. So we could say, it's independent for x. So in example 3, it says Armando works as a street sign advertiser for a local restaurant. He is paid $10 a shift plus 50 cents for every customer who comes into the restaurant during his shift, up to a maximum of $100 per shift. Determine the domain and range of the function that describes Armando's daily wages. So for the first part, it says express using function notation. So we're going to say write the function. So you can notice how they're going from this text to this function. So again, you have to be careful, take it one part at a time, underline, circle, whatever you may need to do. Highlight might be a good option too. So notice how it's, we said f of x is going to be what? Amount of money earned. So yeah, this is f of x is amount of money earned. We have the $10 just as a flat rate every time he works, but the 0.5 is the 50 cents for every customer. So we're going to say the x equals number of customers. And we're going to say, let's say f of x equals money earned. Okay. So now it says determine the lower and upper bounds of the domain. And what that means is, the far, if we're looking at the graph, we're talking far left and far right value. Or you can say something like the lowest value and the highest value. because if we're thinking about our problem, we're not going to have negative customers because that's not possible. But if we are talking about our highest value, we would have to have a constraint because we can't make more than $100. So it says if no constraints given by the problem, the solution is the set of all real numbers, which is like this. I can also say, make a little bracket. I would say negative infinity less than x less than positive infinity. That's all it's talking about. It's any number from left to right. So our lower bound for our domain is the fewest number of customers I can visit is 0. And that makes sense because, say no one came out, we can't have negative numbers because we don't have negative customers. So it's just going to be the smallest value is going to be 0. And then it says for the upper bound, there's nothing limiting the number of customers that can visit the restaurant, so there is no upper bound. So we're going to say that's going to be positive infinity. Okay. Then it says determine the lower and upper bounds of the range. So we're talking about still y values, which is far bottom and far top. And we say often this comes from the lowest and highest values from the input, but not always. So we have to kind of use both the x and the y to be able to figure out what we're doing. So our lower bound, meaning the lowest amount Armando can make, is $10 because when we plug in 0 in for x, this goes away and the only thing that's left is 10. So that's going to be our lower bound for the y values. Then we're going to say for our upper bound, if enough customers came, then Armando would hit his maximum salary of $100. So the way we write this, express the domain and range as inequalities. So again, you can use them like this. You can also, again, if only one side is bounded, you can use a simple inequality. You can also say it like this if you wanted to say, like I had before, I would say I have 0 less than or equal to x less than positive infinity is another way of writing it. But I can't change this one because this one is clearly defined. So this is going to be our range. Again, f of x just means y. So this is how you would express your domain and range given this situation. So you want to make sure that you can write the function and come up with the domain and range. So let's do that in these examples. So let's practice it. It's evaluating functions, domain, and range. So we're going to do a couple things all at once. So it says functions can tell us general rules for a situation, while evaluating functions tells us what specific outcomes will result for specific inputs. Practice evaluating functions and identifying domain and range for each of the scenarios below. If no limit is specified, assume that the quantity is not bounded. So we're going to say like this, we're going to say, okay, we have Taylor makes $13 per hour at the grocery store. She always works between 10 to 15 hours per week to leave time for her homework and band practice. Her gross wages, meaning overall, can be modeled as W of H equals 13H, where H is the number of hours worked per week. So for part A, it says how much will her gross wages be if she works 12 hours this week. So what we're going to say is that we're going to say, okay, we have our function already written right here. And so all we have to do is we have to plug in for H. So I'm going to say, okay, I have W of 12 equals 13 times 12, which is equal to $156. So real simple. And it says part B, what is the domain of this function? Well, we're going to say this. We're going to say you're going to use, since it's talking about hours, we're going to write it like this. We're going to say it's going to be in between 10 and 15 hours. Again, writing it like an inequality. And then the amount possible that she could earn would be this. I would say our function, so it would be our lowest amount would be 13 times 10, which would be $130, in between W of H, which is in between the maximum, which would be 15 times 13, which would be 195. So that's how I get my 2 pounds. Then for number 2, it says Susan earns 0.5% interest annually in her savings account. She can model her savings account balance after earning interest for a year as f of x equals x plus 0.005x, or just f of x equals 1.005x, where x is the account balance. So then it says, what will be her account balance after a year if she started with 30,000 in her account? So that's just plugging in 30,000 into the account for x. And so I can say I have f of 30123 equals, and I'm going to say I have 1.005 times 30,000, which is equal to 30,150. So what's going to be our domain for this one? Well, our x value, again, we can maybe have $0 in our account, so we can say, something like this. We can say 0 less than or equal to x less than infinity, because maybe we have an upper bound of infinite dollars, which would be tough to do, but it is possible. And then what is the range for this one? Meaning f of x would be amount earned, or sorry, x is in the account and that's earned, so this would be the same idea. You can say 0 less than or equal to f of x less than positive infinity as well. So similar idea, again, we're finding domain is x values and range is those y values, meaning f of x. So now I want to give you a chance for your turn. I'm going to say that both of these are, so these three, I'll try that again. These three are your turn, and these 4 are also your turn. Again, make sure your turn. Again, try them out. Make sure you can ask for help if you need it. And as always, super slam that subscribe button.